Good night, guys. It's me, Aradhi Gopal Nepal, and today I'm going to explain. Today I'm going to read about state management. Okay, what is this actually? Yes. YouTube. Let me check. यो पङ्खा सफा गर्नुपर्छ पङ्खा सफा गर्नुपर्छ
मेरो पनि मोबाइल यसको गर्नु सफा
Okay, guys, let's begin. So yesterday I was like here. Okay. So let's begin, guys. Today I'm going to read this whole paragraph, and then this paragraph, and also this paragraph, this and this. So let's begin. Differentiate between ephemeral state and app state. Ephemeral state, app state, there is no clear-cut rule. This talk introduces app state, ephemeral state, and how you might think is in a Flutter app. So let's begin, guys. I will read all of this, so do not rush. In the broadest possible sense, the state of app is everything that exists in memory when the app is running. This includes the app assets, all the variables that the Flutter framework keeps about the UI, animation state, textures, font, and so on. While this broadest possible definition of state is valid, it's not very powerful for architecting an app. First, you don't even manage some state like textures. The framework handles those for you. So a more useful definition of state is whatever data you need in order to rebuild your UI at any moment in time. Whatever data you need in order to rebuild your UI at any moment in time. Second, the state that you do manage yourself can be separated into two conceptual types: ephemeral state, app state. Ephemeral state, sometimes called as UI state or local state. Okay, ephemeral state means UI state or local state is the state you can neatly contain in a single widget. This is intentionally a vague definition, so here are a few examples. Current page in a page view, current progress of a complex animation, current selected tab in a button navigation bar. Other part of widget tree seldom need to access this kind of state. Other parts of the widget tree seldom need to access this kind of widget. There is no need to serialize it, and it doesn't change in complex ways. In other words, there is no need to use any state management techniques, scope, model, redux, etc. on this kind of state. All you need is stateful widget. Below, see how the current selected item in a button navigation bar is headed in the index field of the my local state class. Index is ephemeral state, भनेको local state only scoped inside this class. Here, using set state and a field inside the set state widget is completely natural. No other part of the app needs to access index. The variable only changes inside the my home page widget, and if the user closes and restart the app, you don't mind that index resets to 0. App state that is not empirical, that you want to share across many parts of your application, and that you want to keep between user session is what we call application state, sometimes called this shared state. There is something called local state, and there is something called shared state, and empirical state, local state. Okay, example of application state: user preferences, login info, notification in social networking app, the shopping cart in an e-commerce app, read unread state of article in news app. For mapping app state, you will have to research your option. Your choice depend on complexity and nature of your application. your team's previous experience and many other aspects. Read on. So app state could be local or backend or in an state management package. To be clear, you can use state and set state to manage all the state in your application. In fact, the Flutter team does this in many simple app samples, including the starter app you get with every Flutter create. It goes the other way too. For example, you might decide that in the context of your particular app, the selected tab in a button navigation bar is not empirical state. You might need to change it your outside the class, keep it between sessions and so on. In that case, the index variable is app state. There is no clear-cut universal rule to distinguish whether a particular variable is empirical or app state. Sometimes you will have to refactor one into another. For example, you will start with some clearly empirical state, but as your application grows in future, it might need to be moved to app state. For that reason, take the following diagram into a large grain of salt. Data, what needs it? Most widget, some widget, single widget. Most widget, single widget, then use app state. Or if a single widget needs that data, then use empirical state. When asked about React set state versus Redux store, the author of Redux then replied, do whatever is less awkward. In summary, there is two concept types of state in Flutter. Empirical state can be implemented using state and set state and is often local to a single widget. The rest is your app state. Both type have their place in any Flutter application, and the, the split between the two depend on your own preferences and complexity of the application. Simple app state management. So guys, now I am going to read all of these. I don't know how much time it needs. Maybe 15 minutes more. Simple app state management. Data and backend state management. Simple app state management. Context. Our example, lifting state up, accessing the state, change notifier provider, consumer, provider of, putting it all together. Now that you know smart. Now that you know about declarative UI programming and the difference between empirical and app state, you are already to learn about simple app state management. On this page, we are going to be using the provider package. If you are new to Flutter and you don't have a strong reason to choose another approach, Redux, RX, hooks, etc., this is probably the approach you should start with. The provider package is easy to understand and it doesn't use much code. It also uses concepts that are applicable in each other approach. That said, if you have a strong background in state management from other reactive framework, you might find packages and tutorial listed on the options page. Our example. For illustration, consider the following simple app. The app has two separate screens, a catalog, a card represented by the My Catalog, My Card widget respectively. It could be shopping app, but you can imagine the same structure in a simple social networking app. Replace catalog for wall and card for favorites. The catalog screen includes a custom app bar, My App Bar, and a scrolling view of many item list, my list items. Here is the app visualized as a widget tree. App, my catalog, my cart, my app bar, my list item, my list item, my list item. So there are many. So we have 5 subclasses of widget. Many of them need to access to state that belongs to eligible. For example, each my list item need to be able to add itself to the cart. It might also want to see whether the currently displayed item is already in the cart. This takes us to our first question. Where should we put the current state of the cart? lifting lifting the state up, lifting the state up, lifting state up. In Florida it makes try let me blink. In Flutter, it makes sense to keep the state above the widget that use it. Why? In declarative framework like Flutter, if you want to change UI, you have to rebuild it. There is no easy way to have my card update with something new. In other words, it's hard to imperatively change a widget from outside by calling a method on it. And even if you could make this work, you would be fighting the framework instead of letting it help you. Void my tab handler void card somehow get my card widget dot update with item. Even if you get the above code to work, you would then have to deal with the following in the my card widget. Bad, do not do this. Widget build uh, some widget instead of widget update with. Somehow you need to change the UI from here. You will need to take into consider the current state of the UI and apply the new data. It's hard to avoid bugs this way. In Flutter, you construct a new widget every time it's constant changes. Instead of my card update with something new, a method called use my card contains a constructor because you can only construct new widget in a build method of their parents. If you want to change content, it needs to live in my card's parent and above. Card.add and my card has one code path for building any version of UI widget context. In in our example, content needs to live in my state whether whenever it changes, it rebuild in my card from above. More on that later. Because of this, my card doesn't need to worry about life cycle. My card doesn't need to worry about life cycle. It just declares what to show of any given content. When that changes, the old my card widget disappears and it completely replaced with new one. My app card. This is what we mean when we say widgets are immutable. They don't change, they get replaced. This is very important line. Very important line, guys. I, this is what we mean when we say that widgets are immutable. They don't change, they get replaced. Now that we know where to put the state of the card, let's see how to access it. I'm talking too much today, guys. Okay, slow down, yeah, let's slow down. Accessing the state. When a user clicks on one of the items in the catalog, it's added to the cart. But since the cart lives above my list item, how do we do that? A simple option is to provide a callback that my list item can call when it is clicked. Darts functions are first class objects, so you can pass them around any way you want. So inside my catalog, you can define the following. Oh my tab, okay, bro. This works okay, but for an app state that you need to modify from a different places, you have to pass around lots of callback, which gets old pretty quickly. Fortunately, Flutter have mechanism for widget to provide data and services to their descendants. In other words, not just the children but any widget below them. As you would expect from Flutter, where everything is a widget, these mechanisms are just some kind of widget. Inherited widget. OMG, bro, I didn't know about that. I knew this, but I never knew about these two. Inherited notifier, inherited model, and more. We don't be covering those here because they are a little bit low level for what we trying to do. Instead, we are going to use package that works with low level widget, but it is simple to use. It's called provider. Before working with provider, don't forget to add dependencies on it your popspec.yaml. Popspec.yaml. To add the provider package as a dependency, run flutter pub add Flutter pub add provider. Now you can add now you can import package provider.dart and start building. With provider, you don't need to worry about callbacks or inherited widgets, but you do need to understand three concepts: change notifier, change notifier provider, consumer. Change notifier. Change notifier is a simple class introduced in the Flutter SDK which provides change notification to its listener. In other words, if something in a change notifier, you can subscribe to its changes. It's form of observable for those familiar with the term. In provider, change notifier is a way to encapsulate your application's state. For very simple app, you can get with a single change notifier. In complex ones, you will have several models and therefore several change notifier. You don't need to use change notifier with provider at all, but it's an easy class to work with. In our shopping app example, we need to manage the state of the card in change notifier. That extends its we create a new class that extends it like so. The only code that is specific to change notifier is the call to notify listener. Call this method anytime the model changes in a way that might change the you. Call this method call this method anytime the model changes in a way that might change your app's UI. Everything else in card model is the model itself and its business logic. Change notifier is part of Flutter Foundation and doesn't depend on any high level classes in Flutter. It's easily testable. You don't even need to use widget testing for it. For example, here is a simple unit test card model. Hey, card model. Ah, nice, bro, nice. Okay, you card, you create a card, total price. Okay, you can. It's observable, so we can test change notifier easily. Change notifier provider. Change notifier provider is a widget that provides an instance of a change notifier to its descendants. It comes from the provider package. We already know where to put change notifier provider above the widget that need to access it. In this case of card model, that means someone above both my card and my catalog. You don't want to place change notifier provider higher than necessary don't want to pollute because you don't want to pollute the scope. But in our case, the only widget that is on top of both my cart and my catalog is my app. Run my app. Note that we are defining a builder that creates a new instance of card model. Chinware provider is smart enough not to rebuild card model unless absolutely necessary. It also automatically calls dispose on card model the instance is no longer when the instance is no longer needed. If you want to if you want to provide more than one class, you can use multi-provider consumer. Now the card model is provided to widgets in our app through the change notifier provider declaration at the top. We can start using it. This is done through the consumer widget, return consumer card model, builder, context, card, child, return, text, total price, card, total price. We must specify the type of the model that we want to access. In this case, we want card model, so we write consumer card model. If you don't specify the generic card model, the provider package won't be able to help you. Provider is based on type, and without the type, it doesn't know what you want. The only required argument of the consumer widget is the builder. Builder is a function that is called whenever the change notifier changes. In other words, when you call notify listener in your model, all the builder method of all the corresponding consumer widgets are called. The, the builder is called with three arguments. The first is one is context, which you got, which is which you also got in every build method. The second argument of the builder function is the instance of change notifier. It's what you were asking for in the first place. You can use the data in the model to define what UI looks like at any given time. The third argument is child, which is there for optimization. If you have a large widget subtree under your consumer that doesn't change when the model changes, you can construct it once and get it through the builder. You can do this. First, you will set this and you can do this. The best practice to put your console widget is as deep in the tree as possible. You don't want to reveal large portion of the UI just because some small detail somewhere changed. Don't do this. Do this. Provider op. Sometimes you don't really need the data in the model to change the UI, but you still need to access them. For example, a clear cart button wants to allow remove everything from cart. It doesn't need to display all the content of the UI. It just needs to call the clear method. We could use consumer for this, but that would be wasteful. You'll be asking the framework to rebuild a widget that doesn't need to rebuild. For this use case, we can use provider of with the listen parameter set to false. Using the above line in a build method won't cause this widget to rebuild when notify listener is called. Putting it all together, you can check out the example covered in the article. If you want something simpler, see what this simple counter app looks like when built with provider. By following along this article, you will create improved with your ability to create state-based applications. Try building an application with provider yourself to master these skills. So guys, that's all. My mouth getting dry. I will drink water. Bye bye.